Hello everyone, I am Ghala Shalabi. Today I will talk about our project which is about eye-controlled wheelchair. Our idea is considered as an important issue in Saudi Arabia because according to recent statistics said that 1500 cases of spinal cord injury that causes paralysis are recorded every year in Saudi Arabia. Paralysis can be caused by accidents or injury or genetic diseases. Paralysis has several types according to the paralyzed area. Our main focus in this project will be on quadriplegia and amyotrophic lateral sclerosis or ALS. So, both patients cannot use the manually powered wheelchair or even the electric wheelchair. So this leads us to our project goal, which is to provide a hands-free method for controlling the wheelchair by tracking the patient's eye movement.
So in order to demonstrate the system operation process, the block diagram was created. First, the system consists of two functional subblocks, starting with the first subblock, which is responsible for monitoring and recording the eye's direction, which is placed in the eyeglasses. Two reflectance sensors are placed to the right and the left of the eye, and the combination of their signals can indicate the position of the iris. The reflectance sensors emit infrared light at the user's eyes, and then the light is reflected back to the sensors in order to determine the eye's position. Then these signals are fed to the microcontroller in order to be transferred to the other subblock. And the communication between the two subblocks are done wirelessly by using wireless serial communication module. So moving to the second subblock, which is placed in the wheelchair prototype, a proximity sensor with type ultrasonic was used in order to ensure that the area around the wheelchair is free from obstacles. So once an obstacle got detected, it will reflect the ultrasound waves to the sensor. So the signals that come from the ultrasonic sensor and receiver communication module are both sent to the microcontroller, and both signals are used to control the wheelchair's movements. And then the microcontroller will send the corresponding signals to the DC motor driver. The DC motor driver is responsible for controlling the two DC motors' speed and direction. So if any obstacles got detected, the microcontroller will send the stop signal to the DC motor driver to stop the motion of the wheelchair. Here is a visual representation of how this project will work. So when the user wears the eye tracker that contains the reflectance sensor, so the reflectance sensor will emit the infrared light, and then the infrared light will be reflected to the sensor in order to determine the eye's position. So if the user looking to the right side as shown, the wheelchair then will turn to the right. And when the user looking straight forward, so then the wheelchair will move straight forward. And when the user looking to the left side, the wheelchair then will turn to the left.